Welcome to our physics classroom. And good day, everyone. I hope you are doing fine and you are done with the last activities that I've sent you, and you are now ready to answer our new learning activities. Okay, last time we discussed about wave and damp oscillation. Okay, before we discuss our new lesson, I have some questions. What will happen when two waves meet while they travel through the same medium? Ano nga bang mangyayari when they meet together in the same medium? Another one is what will happen to the meeting of the wave upon the appearance on the medium? And the other one is will the two waves bounce off each other upon meeting, just like what happened to the two billiard balls? Or will the two wave pass through each other? Magtatama ba sila? Magbabounce ba sila from one another? Or they will pass through each other? Ano nga bang mangyari when two waves meet in same medium? Okay, for you to answer that, it has something to do with wave interference, which is our lesson for today. So, what is wave interference? Okay, so wave interference is a phenomenon. When we say phenomenon, meaning it is naturally occurring. Okay, and when we say wave interference, it is a phenomenon that occurs when two waves meets while traveling along the same medium. Yun pala. So, when two waves meet in a same medium, no, let's say for example in an air, that is the medium, and we have sound waves per se. So when these two waves meet together in a same medium, so they exhibit wave interference. Another one, the interference of wave causes the medium to take on a shape that result from the net effect of the two individual waves upon the particles of the medium. So later on, for you to understand the meaning of this, we will have illustration for this one. So this one is an example of wave interference. I have here a pulse here and another pulse here, and then when they meet together in the same medium, what will happen? So as you can see, okay, so meron tayong dalawang waveform. No, ito yung wave natin, ayan. So that is an example of wave interference. Okay, so interference of two wave is very simple concept and even easier to calculate. We can calculate pala when we have interference of this wave. Simply, we will add each point in the same place on each wave to get the resultant wave. So, parang arithmetic lang. I-add lang natin yung displacement ng dalawang wave so that we can calculate the resultant wave or the uh, sum of this wave. So we have two types of wave interference. The first one is constructive interference, and the second one is destructive interference. So let us define first what is constructive interference. So constructive interference is a type of interference that occurs at any location along the medium where the two interfering waves have displacement in the same direction. So tandaan nyo dyan, same direction. That is an interference where two waves traveling in the same direction. So that is constructive interference. For you to understand more, here's the example of a constructive interference, yung binigay ko kanina. So these two waves traveling in the same direction. So, what will happen to the effect of the waves? So, they combine together forming a standing wave. So, constructive interference, in order for you to understand in addition with them, so let's say for example, I have here a two waves. So, the wave A or the pulse A, we can also tell it as a pulse, and also pulse B. So, they are traveling in the same place, no, same medium and same direction. What will happen? So we will add them together. So A plus B, then we have the standing phase. So during the interference, this will be the effect of this two wave. And we call this interference as constructive interference. After no interference, they will go back to their original form or ganun ulit. Another, let's say in this example, no, para makita natin what will happen when we have two waves. So I have here displacement, may line tayo dyan para may sukat. So as you can see, this dot black plus dot black, this is the sum. And green plus green, this is the sum. So, that is, and blue plus blue, and that is 2. So, ganun siya. So, that is 1 plus 1 is 2. Ayan. So, parang pinagsama lang natin sila together. So, this will be the final form of the wave during the interference. And kapag ganyan yung nangyari sa ating wave, they do constructive interference. So, another example for this one. So, we have wave 1 and we have wave 2. And this is the resultant wave or ito yung sum ng dalawang wave natin. Let's say that this x is the displacement of this wave. So, x plus this wave, same direction, so we have 2x. And another one, on the other hand naman, yung trough natin, no, sa baba. So, trough to trough. So, negative x. So, negative x plus negative x, that is negative 2x. So, as simple as that. And that process is what we call constructive interference. Now, how about destructive interference? Destructive interference is a type of interference that occurs at any location along the medium where two interfering waves have displacement in the opposite direction. Kanina, sa constructive interference, same direction. What will happen naman kaya if that is opposite direction? And we call it as destructive interference. For you to understand it, let us have an illustration. So this one is an example of destructive interference. So we have here the direction of this wave or this pulse is in this direction as ito naman dito. Okay, so that is an example of destructive interference. So let us look it into detail. Let's say I have here pulse A and pulse B, or wave A and wave B. So they are traveling in opposite direction. So this one is upward and this one is downward. So we have here the crest and we have here the trough. We know that the highest position of the wave is the crest and the lowest position is the trough. So adding them together, it will result to this one. So, cancel out. Kasi nga, this one is positive and this one is negative. So, this one will be out. But after the interference naman, that is happened during interference. After the interference, it will go back to its original position. Yan. So, ganun ulit. Kaya lang, ito yung ating V, ito yung ating A. Nagkapalit na sila kasi pag ganun yung position ni B, di ba? Ayan pa rin. Tapos, ito naman si A. Ito pa rin yung posisyon ng ating A. So, balik pa rin. Kaya lang, pagka nagsama silang dalawa, it will be canceled out kasi they traveling in opposite direction. So, let's say in this example, so we have here the dot blue plus dot blue. So, opposite yung side na yan. So, cancel out. This one is also this one. Dito sa green. Cancel then and blue. So, when wave traveling in opposite direction, we call it as destructive interference. And both of them will go to the equilibrium position or zero position. Pero during interference lang yan. Okay, so for you to see it, let's say I have your x, that is the displacement of this wave 1, and we have also wave 2. Ayan, opposite. So, that is x plus negative x, so that is 0. In this case naman, we have here sa trough naman, dito naman ay sa crest. So, we have negative x plus positive x, 0 pa din yung resultant. So, laging 0 ang resultant ng ating destructive interference. So, as simple as that. So, combine lang natin together yung ating illustration kanina. Ayan. Para mas ma-compare natin. Let's say for wave interference, we have destructive and constructive interference. So, this one is constructive interference and this one is destructive interference. As you can see, let's say we have wave 1 and wave 2. Same with this direction. So, ano mangyayari when there is a constructive interference? We will combine them together. And ito combine din natin, kaya lang ang magiging result is 0 since they are traveling in opposite direction. Ito in same direction. Ito yung ating standing wave. Okay. Okay, if you want to illustrate the constructive and destructive interference through experiment, you can do it using the rope. So, just like in this example, so, yung direction ng ating wave here is in opposite kasi binibrate niya in this side. Ito naman yung rope, binibrate niya pa ganon. So, ang mangyayari, opposite direction yung wave. Dito naman sa point na ito nangyaring interference. So, as you can see, they do destructive interference nag-cancel out dito sa part na to. And this is an example of destructive interference. Since wave rope is an example of mechanical wave, no? And rope itself is the medium itself, no? So this one is an example of destructive interference. Now, let us move to the principle of superposition and a wave. Yung kaninang ina-apply natin when we add waves is we follow the principle of superposition and a wave. So, what is this principle? It says that when two waves interfere, the resulting displacement of the medium at any location is the algebraic sum of the displacement of the individual waves at the same location. So, yung ginawa natin kanina where we add waves, even they are traveling in same or opposite direction, is we follow the principle of superposition. For more example, let us have another one. So let's say I have here wave 1 and wave 2. Following the principle of superposition, this would be the resultant. So how is it? Let's say I have here, this is the crest, wave 1 and crest 1. So, that is positive x, positive x. So, we have 2x. So, kaya ito yung mas tumaas yung wave natin, yung displacement niya, pinagsama. In this case naman, we also have same direction pa rin, trough to trough. So, ito pa rin yung naging product. So, this one is an example of constructive interference, following the principle of superposition in adding this wave. For this one naman, we have here the opposite. So, ito sa positive side. Ito naman, nasa baba. So, that is negative. Maka-cancel out din yan. And this one is an example of destructive interference. Adding them together follows the principle of superposition. Kaya, ang sagot is 0. So, we have trough here and we have crest here. We know that is in opposite. Cancel out pa din. And then also, cancel out. This one naman, we have trough to trough. So, we add them together, same direction. Dito rin, same direction and same direction too. So, this is constructive. This one is destructive. Sa product pa lang or sa resultant wave pa lang, you'd be able to know what type of interference is being described by the illustration. So, this one is destructive. So, this one is constructive interference. As simple as that. Okay, so this one is a moving destructive and constructive interference. Pansinin niyo, we have two waves, the red one and the blue one. And this one is the resultant wave of them. So, let's say we have crest to crest. Ayan ang product. Pag nagtatama naman yung ating crest to trough, ang nagiging product nila is 0. No? Ayan. So, pag crest to crest, nagkakaroon ng standing wave, mataas yung ating crest. No? Kapag ka naman opposite, so, nagka-cancel out. So, this one is an example of wave interference. So, pareho ini-exhibit nitong example natin ng constructive and destructive interference. Adding them follows the principle of superposition. So, what if naman if non-identicals yung wave natin? No? Hindi sila pareho ng structure. How do we add them? Following pa rin natin yung superposition principle, kaya lang magiging ganito yung itsura niya. Kasi non-identical yung waves natin. As you can see, magkaiba sila ng wavelength. Ayan. Ito, medyo maliliit ang wavelength, maikse. Ito, malaki yung wavelength niya. Pero adding them will be, this one is the resultant. And that is an example lang naman. Just in case, no? And so, paano nga tayo mag-a-add following the principle? Let's say we have here displacement of the pulse A or wave 1 and we have displacement of the pulse 2 or the wave 2. Let's say positive x, positive 1 plus positive 1. Parang arithmetic lang din yan. So, the answer would be positive 2. And let's say we have negative 1 and negative 1. So, same direction pa rin yan kung titingnan nyo. So, that would be negative 2. Parang, ano yan, trough to trough. This one is crest to crest. Another one, so we have positive 1. Ito, crest position. Ando siya sa taas. Ito naman nasa baba, if you imagine it. No, that is opposite. So, that would be cancel out, 0. This one is positive 1 and negative 1. Plus natin yan. So, the answer is negative 1. Ay, negative 2 kasi to. So, kung ima-minus natin, so magiging ganyan. Okay. So, yun lang. Parang arithmetic lang when we follow the principle of superposition. Since we're done discussing about wave interference and we also answered those questions na pinost ko kanina before we start our lesson na ano nga bang nangyayari when waves uh, meet at the same point in opposite and same direction. So they do constructive and destructive interference. Now let us move with another part of our lesson for today, which is Doppler effect. Okay. Doppler effect is a phenomenon observed whenever the source of wave is moving with respect to an observer. So, Doppler effect has something to do with the observer. Later on, you will understand what is the function of the observer to the wave source and how Doppler effect happens. Another one, a shift in the apparent frequency. We can define Doppler effect as a shift in the apparent frequency for a wave produced by a moving source. To illustrate Doppler effect, here is the sample illustration. So as you can see, we have here the observer and the wave. No? As sabi dun sa Doppler effect, as the shift daw, ang Doppler effect is the shift in the frequency of the wave with respect to the observer. So let's say ang observer natin, papalapit siya sa wave, higher frequency, no? Frequency is how many wave are in a certain period of time, 'di ba? How frequent, gaano kadalas. So, dito, mas concentrated, compress yung ating wave kapag papalapit sa observer. Kapag papalayo naman ang ating wave doon sa ating observer, lower frequency. Sabi nga nila, Doppler effect is the shift, apparent shift in the frequency of the wave with respect to the observer. So, that is a simple illustration. Later on, we will have more illustration as we go on. Doppler effect can be observed with all types of wave, mostly water waves, and also sound waves. So later on, magkakaroon tayo example for sound waves and also light waves. So, dito pag light waves naman makikita mo, kaya kapag malapit na tayo sa source ng light, sobrang liwanag, 'di ba? Kapag malayo naman tayo sa source ng light, medyo parang lumalabo na yung light or hindi siya gano'n ka-bright sa atin. It is because of the Doppler effect. Kasi pag mas malapit sa atin yung ating wave, so mas ang frequency niya is high. Kapag malayo, just like this one, lumalayo yung ating light, so nagkakaroon ng lower frequency. Dito naman, papalapit. So that is apparent shift in the frequency because of the observer. It depends of the observer. That is Doppler effect. Okay. Doppler effect could result from several factors. Ba't ba nagkakaroon ng Doppler effect? So, it must satisfy this condition. The first one, the motion of the observer. Let's say, sa light waves. Pag papalapit ka sa light waves, so, tumataas yung frequency nun. Mas bright siya pag malapit ka, 'di ba? Because of the motion of the observer. Pag lumalayo naman ang observer, bumababa sa kanya yung frequency. With respect to the observer kasi ang Doppler effect. Another one is the motion of the source. Kung hindi ang observer ang lumalapit o lumalayo, it's either the source. So, for example, sa sound, no, lumalayo yung sound sa'yo. Kung halimbawa, maandar na sasakyan, may sound wave. Diba? And kapag papalapit sa'yo yung sasakyan na may dalang sound system, rather, okay, so it is either of this one, the motion of the observer or the motion of the source that causes the Doppler effect. Another one is the motion of the medium. So, pwedeng medium itself, no? That is the reason why we have the Doppler effect. So, these are the reason. So, for this lesson, we will focus on the Doppler effect to sounds. Sa sound tayo. Doppler effect is common phenomenon that we observe in our everyday life. So, for instance, you are standing on a footpath just like this girl. You heard a police vehicle approaching in a distance. First, 'di ba? The sound of the siren no nandito is faint and faint, medyo mahina lang and gets louder as the vehicle reaches close to you. So, habang papalapit 'yan, lumalakas yung tawag nito, yung sound ng siren. Once the police car cross over you or lumagpas na siya dito and goes ahead, 'di ba? The sound gradually decreases again. This effect is basically known as the Doppler Effect. So, habang lumalapit yan, mas lumalakas yung sound. And then, pag lumayo na sa'yo yan, lumagpas na, papalayo na yung sound. Pero yung totoong yan, hindi nagbabago yung frequency ng sound ng siren. Nagbabago lang siya because of the observer. It depends on the observer. And that is Doppler effect. So, and at the same time, makikita nyo dito, kapag malayo sa kanya yung source ng sound, yung wavelength natin, no, is long, malaki. Later on, and wavelength is, um, opposite or what you call this, inversely proportional to the frequency. As the wavelength is increases, the frequency decreases. Dito naman, as the wavelength decreases, small waves lang, the frequency is higher. No? Kaya mas matinis, mas ma-high pitch or mas malakas yung sound pag malapit sa atin. And that is Doppler effect. So let's put into detail. No, as a car approached with its siren blasting, the pitch of the siren sounds, a measure of the siren's frequency was high. And suddenly, after the car passed by, the pitch of the siren sound was low. So, as you can see in this example, pag malayo yung ating sound from the observer, let's say you are the observer here, the wavelength is larger or long. And since the wavelength is long, the frequency is low. Frequency and wavelength are inversely proportional. On the other hand naman, dito naman, the wavelength are shorter, making the frequency higher. No? So, kaya that is the reason why habang lumalapit yan, mas tumataas ang frequency, mas nagiging high pitch yung sound, yung dating ng sound sa ating observer. That is the reason why we have this Doppler effect on sound. For better understanding, this one is another example. If as you can see, if the distance is large, so this one is the observer. So when distance is large, the waves can be spread apart. So mas spread out siya. Ngayon, yung distance, as lumiliit yung distance from the source and the observer, the waves are compressed, making it smaller. Smaller distance between them, higher frequency. Larger distance would be lower frequency, but larger wavelength rather. So that is example. The Doppler effect is observed because the distance between the source of the sound and the observer is changing. So, nagkakaroon lang tayo ng Doppler effect because yung ating source ng sound or yung observer natin doon sa ating sound mismo, nagkakaroon ng pagbabago doon sa kanilang distance or the distance between the source and the observer. Let's say if the source and the observer are approaching to one another, so the distance is decreasing. So nagkakaroon ng change sa kanyang frequency with respect to the observer. And if the source or the observer are receding, so magpapalayo, let's say papalayo sila from one another, the distance between them is increasing, causing to the apparent shift in the frequency of the sound wave. But even though there is a change in the distance between them, causing them to change in frequency, you have to remember this thing. The source of the sound always emits the same frequency. Yung frequency na imi-emits ng ating sound doon sa ating source, always the same. Nagkakaroon lang ng pagbabago with respect to the observer. And that effect is what we call Doppler effect. Since we're done defining Doppler effect, let us proceed with the calculation. For you to be able to do calculation regarding Doppler effect, you have to know and understand first what is the equation for this topic. So here is the formula that we're going to use to solve problems involving Doppler effect. So F sub O is equal to B plus minus B sub O over B plus minus B sub S multiplied by F sub S. For you to understand it more, let us have legends. F sub O is the observer frequency of sound. So, ito yung naririnig ng ating observer. No? Yung frequency ng sound niya. And V is the speed of the sound itself. And B sub O is the observer's velocity. So, if the observer is moving, so meron siyang velocity. Another one, if the source is moving, so meron din siyang velocity, and that is B sub S. And the actual frequency of the sound itself is the F sub S. So, we're using this in solving the problem. When dealing with problems regarding Doppler effect, we have to take note of the sine rule. So, let us proceed with the first rule. For sine rule, the first rule is the sound speed is always positive. So, yung sound speed natin, it will never be negative. Lagi siyang positive. Another sign is for the sine rule for the observer speed or yung ating B sub O. So, ano nga ba yung mga rules dyan? Kailan siya magiging positive? Kailan siya magiging negative? So, the first condition is that the observer speed P sub O is positive if the observer is moving toward the source. So, kapag yung ating observer, papalapit siya dun sa ating source, the V sub O is positive. On the other hand naman, kapag palayo siya sa ating source, yung ating observer, yung speed niya is negative. So, that is the rule. Another one, we have the sine rule for the source speed. Kanina, for the observer speed. Dito, we have the source speed or the B sub S. So, ang first rule, kabaliktaran siya nung kanina. Kapag papalapit ang ating source sa ating observer, ang ating B sub S is negative. Kabaliktaran nung kanina, pag papalapit doon is positive. Dito, pag papalapit tayo dun sa ating observer, that is negative. On the other hand, kabaliktaran din nung ating observer, kapag naman siya ay papalayo doon sa ating observer, yung ating source, yung sound natin, pagpapalayo, that is positive. So, magka-opposite sila. And, paano naman kapag nakahinto ang ating observer o kaya yung sound? So, here's the rule. The observer speed is 0. Siyempre, nakahinto. So, ang speed niya is equal to 0. Kapag naman naka-address din ang ating source, 0 din yung kanyang speed. So, you have to remember those rules in solving the Doppler's effect equation. So, later on, i-apply natin siya when we do solving. So, we can now proceed with the calculation in the Doppler effect. Before we start, may I request everyone to have your paper, your pen, your pencil, and or everything that you need in solving the problem. So, let's start with this problem. Let's read this one. A source of a sound moving towards the stationary observer at 20 meters per second. The frequency of the source of the sound is equal to 380 Hz. The speed of the sound wave in air is 400 meters per second. What is the frequency of the sound waves heard by the observer? If you want to try to solve the problem, you might try to solve this one. But you have to consider the sign rule that I've shown you a while ago in solving this problem. So let's start. Let's find the given, the required, the equation, the solution, and the answer. In the problem, it was stated that the source of the sound is moving towards the stationary observer. So this 20 meters per second is the speed of our source. So that is the B sub S. From the problem, it was stated that the observer is stationary. So, meaning yung ating observer here is nakahinto, stationary. So, B sub O would be equal to 0. So, I've told you that if the observer or the source is at rest, so the velocity or the speed is equal to 0. And another one from the problem, sabi dyan, the frequency of the source of the sound is 380 Hz. So that is this frequency of the sound and that is the F sub S. So that is 380 Hz. Another one, the speed of the sound, which is always positive, is equal to 400 meters per second. So let's put it on the given. So sabi dyan sa problem, we have to find the frequency of the sound waves heard by the observer. So, ang nanap natin, ano kaya yung maririnig dyan ng ating observer? Ano kaya yung frequency ng naririnig ng ating observer? So, that is the F sub O. So, equation natin is this one. So, V plus minus B sub O over V plus minus B sub F multiplied by f sub s. So, ngayon, kanina, meron tayong sign rules. Kasi dito makikita nyo sa gitna, meron tayong positive, negative, positive, negative. So, hindi naman pwedeng yan ang igamitin natin. Depende ngayon kung ano ang magiging sign ng ating observer at ano ang magiging sign ng ating source. Depende yon sa problem. So, from the problem, lagay lang natin agad yung equation natin. Okay, that would be B is equal to, hindi natin alam yung sign niya, B sub 0, ito ng B sub S, hindi rin natin alam ang sign nila. So, from the problem, ang sabi dyan, yung ating source is, yung ating observer rather, is stationary. Kapag stationary or at rest ang ating observer, we can denote the sign ng ating B sub O as positive. Okay. Ang sabi naman dyan, yung source natin is moving towards the observer. Papunta siya sa observer. Dun sa ating rule, kapag ang source natin or VS is papunta sa observer, that is negative. Pagpapalayo, that is positive. Since the problem, sabi papunta, moving towards, so that is negative. So, ang gagamitin nating sign is negative. Okay, so ito na yung formula na gagamitin natin. So, we can now substitute this given to the problem. So, let's put it on the problem. So, this is the value of the speed of the sound sa 400 meter per second plus 0 since ang ating observer is 0, ang speed. 400 meter per second, again, that is the speed of the sound, minus the speed of the source, which is 20 meter per second, multiplied by 380 hertz. So, solving this problem will give us the answer. The frequency of the observer heard by the observer is equal to 400 Hz. So, napakasimple lang. Kailangan tama lang magiging equation nyo dito. Tandaan, sa observer, kapag papalapit, positive. Kapag yung observer papalayo sa source, negative. Ito namang ating source naman, kapag siya ay papalapit, negative. Pag papalayo, positive. Magka-contrast sila. So, if tama itong magiging equation nyo, so you will get the final answer. I hope you have the same answer with me. Now, let us have the second problem. Let us read. Car A moves at 72 km per hour and car B moves 90 km per hour. Approach each other. Car A honk with a frequency of 650 Hz. If the speed of the sound waves in air is 350 meter per second, then what is the frequency of the sound heard by the driver of the car B from the car A? So, if you want to try to solve this problem, having the reference yung first problem natin, you may try to solve this one. Okay, let's start. Let's find the given, the required, the equation, the solution, and the answer. So, from the problem, it was stated that car A moves 72 km per hour. So, let's put it on a given. Yan. Car A, velocity of the car is 72 km per hour and I converted it into meter per second dahil yun naman ang kailangan natin since we're dealing with hertz and we know that hertz is in seconds. So, cycle per second. So, we need to convert it into meter per second. Another one, the velocity of the car B is 90 km per hour. So, ginamit ko yung car A and car B para hindi tayo malito. Later on, aalamin na lang natin kung sino sa kanila yung observer at sino naman sa kanila yung ating source. From the problem, it was said that car A honk. So, siya yung nag-beep, parang nag-beep siya, nag-produce siya ng sound, no? And that sound is equivalent to 650 Hz. So, mula pa lang dyan sa problem, malalaman na natin that the car A is the source of the sound. So, siya yung B sub S. And car B would be the B sub O. And that is the observer. Yung speed daw ng sound produced by that in the air is equivalent to 350 meter per second. So, let's put it on the given. So, from the problem, sabi nga dyan, what would be the frequency sound heard by the car B from car A? So, obviously, car A is the producing sound, is the car that produce sound or that is the source and B is the observer. Mula pa lang sa problem, you'd be able to know. Pero nilagay ko lang yung mismong car A and car B para di tayo malito. So let's put the required as the frequency heard by the car B. So our equation is this one. So ngayon alamin natin what would be since alam na natin that the observer is the car B and that the source is the car A since it produces sound which is equivalent to the 650 hertz, no? Let us know naman ano yung magiging sign nila based on the sign rules. So let's put the equation here. So that is car V as the observer and car car B as the observer and car A as the source. And we have here the car A. Okay, so ang hanapin natin is the frequency heard by the car B. So ano nga ba yung magiging sign nilang dalawa? So ano yung magiging sign ng ating observer car B and sign ng ating observer car A? So from the problem, sabi dyan, car A is approaching one another. Car A hung with the frequency. So approaching one another. So yung ating car B and car A is papalapit sila sa isa't isa, no? So kapag ka daw ang ating observer is papalapit sa ating source, so ang ating sign would be positive. Opposite naman yun ng ating source. Kapag ang source natin is papalapit sa observer, ang ating sign would be negative. So, ayan ang ating equation. So, bakit ulit naging positive? Because the observer, according to the rule, pag papalapit siya sa source, positive. Ito namang source natin, pag papalapit siya sa observer, negative. Okay, so I hope you understand this one. So, now, pwede na nating i-substitute yung ating equation or given to the equation. So, let's substitute this one. So, it will be look like this. So, 350, that is the value of the speed of the sound. 350 plus 25 meter per second, that is the speed of the car B, which is the observer. That is positive. And negative naman yung ating source, which is equivalent to 20 meter per second, and that is the speed of the car A. So, and 650 hertz, that is the frequency of the car A. Since car A is the source, so that is Fs, equivalent sa formula. So, we need to find the frequency of the car B. Solving this will give us the answer 738.6 or 739 hertz. So, ganun lang, as simple as that. As simple as that. So, I hope you have the same answer with me. Okay, let us proceed with the last problem. And it is quite tricky than compared dun sa first problem na sinolve natin. Okay, let us have this one. Let us read. A car moving toward a stationary observer that emits 490 Hz sound wave. The beat of the frequency is 10 Hz, so the heard frequency is 500 Hz. If the speed of the sound wave in air is 340 meter per second, what is the speed of the car? So, medyo tricky tong problem natin. Pero we have to analyze it. If you know how to solve this one, you may try to solve this one. Okay, let us find the given, the required, the equation, the solution, and the answer. So, as you can see in the problem, we have 490 Hertz. That 490 Hertz is the hertz of the sound emitted by this stationary object. So, that is the F sub S. So, let's put it on a given. Another one, we have 500 Hertz. 500 Hertz, bakit hindi 10 Hertz ang kinuha ko? Kasi sabi dyan sa problem, yung ating car is moving toward the stationary object. And that stationary object emits 490. And yung beat ng sound is 10. Kaya nga naging 490 plus 10 is 10 Hertz. And also, luckily sa problem natin, binigay naman siya. That the sound heard is 500 Hertz. So, let's put it on the given. So, that is the frequency of the observer. Okay, heard by the observer. Another, we have 340 meter per second. So, that 340 meter per second is the speed of the sound. So, that is the value of our B. Now, sa problem natin, kailangan malaman natin sino si observer at sino si source. Kung babasahin yung maigi, malilito ka kasi may nakalagay dyan, stationary observer and car. Sino kaya sa kanila ang ating source? Kasi may nakalagay na stationary observer, baka ilagay nyo agad na iyon ang inyong observer. You have to read the problem carefully. Sabi dyan, a car moving toward a stationary observer that emits 490 Hz sound wave. Sino sa kanila ang nag-i-emits ng sound? Yung car ba o yung stationary observer? Okay, if your answer is the stationary observer, you are correct. So, in this problem, ang nagpuproduce ng sound sa kanila is the stationary observer. So, kahit na may observer yan, it's just, pampagulo lang siguro para mas mapaisip ka. But that stationary observer is the source kasi siya yung nagpuproduce ng sound. Yung car, hindi naman siya nagproduce ng sound sa problem eh. So, in this case, itong ating observer. Itong ating stationary observer, itong ating source. So, ang speed ng ating source is stationary. Pag sinabing stationary, nakahinto. So, Bs is equal to 0. 0 meter per second. Now, ang hahanapin natin is the speed of the car or yung ating observer. Kasi yung car ang observer natin dito. So, yung speed ng ating observer ang hahanapin natin in this case. So, let's put it on the required. Sana naintindihan bakit naging 0 to? Kasi ang observer natin ay stationary. Yung observer natin dito is not the observer talaga. That is the source kasi siya yung nag-i-emit ng sounds. Kaya siya ay B sub S. 0 for stationary. Okay, the equation to be used would be this one. So, mamaya, bakit itong hinahanap pero hindi na ako nag-derive ng formula? Para mas mapadali tayo, mas madadalian kasi tayo kung i-solve natin siya kahit hindi na tayo mag-derive ng formula. Mamaya ipapakita ni ma'am. And another, isulat natin to. Ngayon, alamin natin what would be the symbol of our observer, speed of our observer, and the speed of our source. From the problem, ang ating observer is the car. And the car is moving towards the stationary or papunta siya dun sa ating source. Kapag ka ang observer ay papunta, so that is, the sign is positive. Okay. And another one, yung source natin nakahinto. So, sabi ko sa inyo kapag at rest sila, ang sign pa din nila is positive. So, plus pa din yan. Kung meron tayong formula, we can now solve it. And we have already the given. So, let's substitute this one. So, 500 Hz, the value of our f sub o, the value of our speed is 340 meter per second. And the value of our observer, speed of our observer is the missing one. Kaya walang nakalagay. And ang ating source, ang speed ng source ay nakahinto, so that is 0. And the frequency of the source is 490 Hz. Ito, frequency ito ng naririnig. Ito ng observer. Ito naman yung frequency ng ating source. Okay. So, from that, isolve natin to. Paano natin isosolve yan? Solve muna natin yung nandito. So, this would be 500, 340 plus b sub 0, 340 plus 0. So, that is 340 meter per second. Next, isosolve natin. 340 multiply natin sa 500. So, nilagay ko siya dito. So, that is 340 times 500 is equal to 340 plus b sub 0. Ayan, ala na siya dito. Kasi, nalipat na dito. Minultiply natin dito sa side na to. And then, 490. So, solve natin ngayon ito. Okay, solve natin yan. That would be 500 times 340 meter per second. So, the answer is 170,000 Hertz meter per second. So, yun yung magiging unit. And now, isolve natin to. That is distribution property, diba? I-distribute natin yan. So, 490 times natin sa 340. So, that is 166,600 Hertz meter per second. Plus, 490 times b sub 0. So, that is 490 Hertz b sub 0. Okay. Solve lang natin, no? Ito, ililipat natin dito, addition property of equality. So, we have 170,000 Hertz meter per second So, naging negative na yon, nalipat dito. So, we have 166,600 Hertz meter per second is equal to 490 Hertz B sub 0. Solving this one will give the answer 3,400 Hertz meter per seconds is equal to, so wala na to, ito yung difference niya, 3,400, 490. So, yan, hindi pa yan tapos, so kailangan natin siyang, kasi yung B sub 0, dapat makancel natin yung 490. So, we have to over them by 490 Hertz. Yan. So, makakancel natin yung 490 Hertz dito sa side na to. So, the answer would be, ito din, makakancel natin yung unit na Hertz. So, ang unit na lang is meter per second. So, solving this will give us the answer 6.9 meter per second. So, I hope you have the same answer with me. So, ganun lang kadali. Medyo basahin nyo lang yung problem para hindi kayo malito. So that is the end of our problem. So if you have question, just message me in my Facebook account or in our Google Classroom or in our Septo LMS for questions. And then thank you everyone. For the learning activities, you can find that on the Google Classroom. So I hope you answer this for this week. So and no more late submission. And thank you.